Brendan from the Achievement Apex. In this video, I'm going to be machining a Pinnacle series squat bar, but tonight I'm going to machine the bar shaft down to its final diameter so that tomorrow morning I can knurl it. Tell you what, it's nearly 8 o'clock at night and it's still hot here. I absolutely hate the summer. Okay, so currently we are facing the end of the bar shaft just to make sure we have a perfectly flat, well-machined reference point. Then I will touch very lightly the outside diameter of the bar shaft, set that to 0, and take off exactly 1.05 mil, which is going to make it finish at just above 35 mil on the dot, which now that I think about it, needs to be 34.75. So we'll do an extra 1/4 mil. You can't see what I'm doing, but over here, I have what's called a digital readout, and the digital readout tells me exactly how far I'm moving the tool in or out, right down to every 5 microns. So you probably can't see this right now, but I just moved the tool in 10 microns. And I've got a digital readout that tells me absolutely instantly as far as it's moving. And that's how you get really precise work on the lathe. So since I've just explained it, I'm gonna retake those measurements because I'd rather be safe than sorry. Okay, so touch it lightly, set to 0, 1.3, okay. Now we can take our pass, and this is at a 0.2 millimeters per revolution feed rate for you machinists watching, if there is any of you. I just turned the coolant down a little bit there to stop myself and my microphone being sprayed. All right, so that's supposed to be just above 34.75. The reason I go just above 34.75 is because I like to finish it off with the belt sander to get an absolute precision, beautiful surface finish. Okay, so that's 34.94. Don't know if you can see that. That's quite a bit above 75, so I'll just take another pass. 84.14 is what we're going to take off. Okay. You can see that the surface finish isn't as good when I do a smaller pass like that, but it really doesn't matter because like I said, I'm going to hit it with the belt sander and it's going to come up absolutely beautiful, polished, like a mirror. Okay, so since we know that 0 is 34.94, I can come out by 60 microns, 0 that, which now I absolutely know that my tool is at 35 millimeters on the dot. So now I can use that to base all of my future cuts that I'm about to make, and they'll all be perfect without measuring. And I'll show you at the end once I've made the cuts that they are on the dot. So we know that the inside diameter of the thrust bearing, the big one, is 25 millimeters. So we're going to be doing 2.5 millimeter passes, and we need to go in 33 millimeters. I'm just turning this manually by hand. I'm not using an automatic feed, but if I was to guess, I'd say this is probably like 0.35 millimeters per revolution, maybe 0.4. That's just a guess. Okay, that's 33. Going another 2.5. Another 2.5 mil. Okay, now this pass I'm going to be going 2.6 instead of 2.5 because I want the thrust bearing to go on without any issues. I just want to be able to slide it on. It doesn't need to be absolutely tight, so I always go that 0.1 mil under. And for this final pass, I am using the automatic feed just to make sure that it's very consistent, beautiful surface finish. Okay, so we'll measure that now and show you. 24.895. That's only off by 5 microns. And I'll grab one of those thrust bearings now just to show you what that's going to look like so. Beautiful. Now we need to machine the next bit down to 20 mils, which is another 5 mil to take off. And this cut needs to go in 23 mils. Then coming in from the end, we need to turn it down to 16.9 mil, and we need to come in 11.5 mil. So we'll go 16, 17, 18, 9, and we'll come in 11.5 mil. And this will be at auto fit. 3, 4, 5. Okay, now we can do some small little chamfers on the edge. I just do these by hand, like so. There we go. Okay, now I can put in my small grooving tool so that I can make a relief for the thread and a groove for the circlip. Okay, now this groove needs to be 1.75 mil deep. 2, 3, 4, 5, 6, 7, 5. And then just clear those chips. And come across here, which will be the relief for the thread. And again, that needs to be 1.75 mil deep. Now we can swap to the threading tool. Now I just use the threading tool itself to do a very small little chamfer right there, and again on the other side. Okay, now this needs to be 1 millimeter per revolution. Loop it up, 0.75 on the first pass, 0.5 on the second pass, and then we will do one final pass, 0.05. The last thing you want is to have a burr on the thread, and then when you're putting on the nut, it gets caught and then the thread gets stuck. All right, so this part here should be 16.9, and we are at 16.885, so we're off by 15 microns. The thread needs to be about like 19.9. This is not super accurate because I've already cut the thread, but right there we're at 0.96, so that's, look at that, everything marvelous. Now the most important thing is to check, does the lock nut actually go on? That is absolutely beautiful. All right, now I'm going to put the tailstock back on the lathe so that I can use the center drill to make a little hole there for the live center. Make sure there's no swarf in that hole. Okay, so literally as I was machining this bar, I thought of a way that I can simplify the process of machining the bars down to diameter, which will make them more enjoyable to do. Because for me, the bar shaft is the least enjoyable part. Sleeves I really enjoy doing. They're really intricate. It's a lot of different operations. It requires a lot of precision. And it's really engaging. But bars are kind of, it's like 3 operations. They all take a long time. It's pretty monotonous and, you know, it's not my favorite thing. Because what I have to do is for this side of the squat bar, I've got to machine this to 34.75 for those 35 millimeter precision bushings. Then I've got to bump it up to 35 for the actual bar shaft. And that's, you know, you got to start and stop, and it's annoying. So I just realized that I can make my own precision bushings, which it doesn't save time, but if I make them in large batches, I can get the time per bushing down to something really low, like 5 or 10 minutes, which means I could machine the entire thing to 35 on the dot, and the performance would be exactly the same. The time, I'd be able to save time on the bar shaft itself because it's just one operation, which will probably negate that time spent making the bushings, plus more enjoyment. And enjoyment is really important for me. There's no reason I should be making bars and fucking hating every minute of it. Because if I hate every minute of it, what's going to happen is, like, I'm going to come down, I'm going to go, oh, like, it's really fucking shit right now. And precision's going to suffer. And that means the athlete who's on the platform using these bars is going to suffer. And that's absolutely not on the cards. So I have to make sure that the process is enjoyable for me and that I feel, you know, I feel happy doing the work. So I'm going to make that change. So for this bar, Down this side, we're going to keep that 34.75, and we're going to make sure it's symmetrical on the other side, 34.75. But for the rest of the bar, this is going to be 35 mil on the dot, and I'm going to keep it that way for all of the bars going forward. The only change going forward will be that this will be 35 as well, saving time, increasing enjoyment, and making sure the athletes have the best product possible. Swap tool right here. So I've got to put some marks on the shaft now. Actually, it might help if I get a steady rest first. Okay, first thing I need to do, like I said just before, is get some measurements. Make some lines. So first one is 359 and 50. So that means I need to come right over here to the end of this sleeve mechanism here. Set that to 0. Come across 359 mils. Make a mark here. Then I need to come across another 50 mil. 20, 30, 40, 50. Make another mark right here. Now the reason I do 2 marks here is because right here is where the bushing is going to go. So that just lets me know that this part here needs to be absolutely precise, you know, plus or minus 50 microns. Whereas this here, nothing's going to touch there. So that part doesn't actually have to be as precise. Okay, then we can swap tool. Use my C-shape external turning tool. The reason I have it nice and close to that steady rest is to maximize the rigidity, which allows me to machine faster. So I'm going to come over here. I'm going to touch this part of the shaft and set it to 0. Okay. So I know that that is 34.8. So I can come out 0.2, set that to 0, and now I know that that's 35. Remembering this part of the shaft doesn't need to be precision. I'll just put the lathe in the right gear. 0.2 millimeters per revolution, and also we want 800 RPM, and send it. Now for this part, which needs to be precision, I know that this steel it's peeled, which is the surface finish of it, it's peeled, and it comes at 36.13 millimeters. So if I just get a 0 right here, there we go. Now I know that that is 36.13. So if I come in 1.1, that's going to be just above 35, which will be perfect for me to finish it off with the belt sander and achieve 35 mil on the dot. Just making sure there's no chips in those bearings to ruin the surface finish. And we'll also speed that up to 0.3, where we were supposed to be. There we go. And I'm sorry for having my hands all in the way of the cutting. I know it's probably not as good viewing conditions, but by having my hand on the steady rest here, it reduces a bit of chatter, and the pliers are to stop any swarf that looks like it might be trying to go under the rollers from getting under there. Usually I don't have an issue at all with chips getting under the steady rest. Honestly, it was more of an issue a year ago, but you know, old habits die hard. A year ago, I had the tools weren't as good. I had to go a lot slower, and the chip breaking was absolutely horrendous. This is why it's important to invest in tooling. Like this tool that I'm using right now, this plus the inserts is nearly $1,000 just for that single tool. I could have kept using my $200 tool, saying I don't want to waste 800 bucks. But in spending that $1,000 for the one tool, I'm able to machine a bar shaft in about 2 hours compared to 6 hours, which saves time, saves money, makes the product cheaper for you guys who are actually lifting on it. It's just a win-win all around. I'll just measure that to see how close we were, to see if I need to do a second pass to finish it off, or if it's good for the belt sander right now. Okay, so that's 35.16, 35.19. Yeah, that's going to be fine once I hit it with the belt sander. I use 2 different grits when I'm using the belt sander. They're all worn, so they're not, exact, but the first one is, 80, and that usually takes off 0.1, and then I hit it with a super worn 240 grit, which is probably more like, honestly, 400 or 500, and that takes off another 50 microns. So it's going to end up probably around 3505 or even maybe, 35. So we'll just finish this off. The reason I stop here, then have to keep going, is I mentioned in the previous video that because I have this steady rest set up, there's a lot more force pushing back against the steady rest here because of the moment arm here compared to over here. So I have to stop and then reset up the steady rest to make sure there's no chatter and stuff going on that's impacting the surface dimensions. Check the dimensions of what we just did. 35.3, 35.25, 35.27. So right here, there's a lot of a taper. Again, it's that same thing where the closer you get to the chuck, it exponentially pushes harder back against the steady rest. It just means we need to do more belt sanding on this side than over this side. What I usually do is with the rough grit, I kind of just go like this, back, forth, going a little further each time. And once I finish with that, it completely gets rid of that taper. So you get a perfectly straight, straight's not the word, but a perfectly parallel bar. These cover the ways to stop any metal dust getting on them, which can wear them out and impact precision. All right, let's see where we're sitting, keeping in mind there's now heat in the bar. So right there, we're on 35.12. So that's probably just right on 0.1, 0.10, 0.14, 0.13, 0.2. Okay, so that's all within half of a human hair, or about 35 microns. The only part that's big is here, which is, I like it to be a bit bigger right at the middle, because when I turn the bar around and do the other side, I like to go back over this bit with the belt sander to merge it seamlessly with the two cuts, which usually takes a little bit more off here and fades it out. So once I hit that again, that'll come down to about 0.1 with the rest of the bar. So I'm going to hit it with the finer grit now to bring it down to about 3505 or 3506, and that'll just make it absolutely beautiful and shiny. Oil the ways. Now, keeping in mind there is even more heat in the bar now, so whatever measurement we get, we can subtract 40 microns. So that's 35.11, 35.1, 35.11, 35.12. So that's a total variability of only 20 microns. If I may say so myself, that's pretty good. We'll move the steady rest over now, and then we'll finish up this little outer bushing brace so that that lands on 0.75. Bring the apron back out, 0.8. All right, let's see how we did. 34.77 with a little bit of heat in the bar, so that's going to be 0.75 right on the dot. Once again, if I may say so myself, I'm good at this game. Now I can make some markings where the knurling is going to go, and that will be this side 100% complete. I think once I've made these markings for the knurling, I'm going to call it a night, because I underestimate how much longer stuff takes when I'm filming and explaining it all, making sure that, all the measurements are precise. It's a common thing I do. I've done it for the last 2 years. I always underestimate how long things take. Plus I'm fucking tired, and I'm not willing to sabotage future me's productivity just for getting a bit more done tonight. I've made that mistake many times where I say, no, tonight I'm going to push, and then the next day or even 2 days, I'm just absolutely fucking wrecked. It's better to focus on maintaining consistent productivity rather than a huge burst in one go, then falling behind, undoing all that progress you gained. Sorry. Okay, so these need to be 0.8 mil deep. Okay, that is 0. Let's get a bit of coolant flowing. Move it over 197.5. Move it over 5. Okay, that's it for this side. So the next lines that need to be put into the shaft, which will go around about here, it's also a 197.5 gap. However, I don't like to do that until I've flipped it around, because once I've flipped it around, I can measure the distance between this line and then the next one over, which will be over here, just to absolutely make sure that if there's any discrepancy in the length of the bar, like even 0.5 mil, that the center line that you actually use to line yourself up when you squat is absolutely precise in the center, right down to the last 0.1 of a mil. So yeah, that is now finished for tonight, and tomorrow morning we can come back and do the exact same thing on the other side. Okay, so I'm just facing the squat bar right now in order to get it to exactly the required length that we need it to be. This is the last pass now. Okay, that is 34.87. 0.87. So I'm going to do a quick pass at 0.07. And that's 34.81, which is just good, because once we hit that with the belt sander, it'll land on 0.75. So that means I can come out 0.19, and that's 35 on the dot. Okay, now we'll quickly shampoo all of those cuts. All right, let's check our work. Beautiful. This should be about 24.9, 24.87. This should be 16.9, 0.865. And here we should be on 19.9. And we are on 19.93. So off by about 30 microns on all of them, which is marvelous. All right, sleeve mechanism is done. We can now move it over, get the whole bar in the lathe, turn that down to 35, then it will be ready for knurling. Okay, it is time to knurl this squat bar. So since I changed the tip, I just have to find my 0 point, my edge of the piece. So I'm gonna go ahead and venture a guess and say that 200 RPM is too fast for this particular operation. Usually I do it at 135, and I thought I'll just try it at 200 to see how we go. See if I could save a bit of time, and it didn't work just then. However, I'm not going to give up just yet. For this threading portion, what I normally do is the first pass I'm usually taking 0.7 off the diameter, and the second I take off 0.1 just to finish it off nicely. If I drop the first pass to 0.6 instead of 0.7, and then increase the second pass to 0.2, we might be able to get the same quality without chipping the tip, and without having to slow back down. So I'll go ahead and I'll try that. Okay, let's put a knurl on these two sections. Then we can move the bar across, find out exactly the middle of this part here, mark it, and then knurl the rest of the bar. Now, another thing we're going to try on this pass is see if we can bump the RPM of knurling up to 800 from 520, because that will save a huge amount of time on knurling, which will just be more enjoyable all round. I've kind of tried it before, but I haven't given it a real test. I was also less experienced when I tried it before. I think the only issue might be heat. So anyway, we'll see how we go. You guys have probably noticed by now that I'm always starting and stopping when I'm knurling. That's to make sure that the knurl is actually tracking properly and the depth of the knurl is exactly where I need it to be for the knurling to be as good as possible. And then once I'm certain that it is good, then I'll let it run. So right now it looks like I need to go a little deeper on it. Well, there we go. We're going to be knurling on 800 RPM from now on, which is going to save, it should be over 50% faster, but I don't think it is. I think the machine doesn't quite have enough power to actually achieve the full 800 RPM. But it's definitely faster than 520s. That's going to save time and money. So very happy about that. We'll go ahead and do the next section now. There's the first two sections knurled. Now we can take the tailstock off the lathe, replace it with a steady rest, move the shaft along, and then find the 0 point here and get it all done. Actually, that stays there. This one here. So what I'm doing right now is just cleaning this knurl up because my coolant is extremely watery right now. Any that's left on the bar will tend to cause it to rust. So I just cleaned up what was on there with terps, and now I just gave it a little coating of oil to keep it happy while I work on the rest of the bar. Okay, so now we can set our 0 point and we can measure the distance between these two marking rings. So we got this one right here. So we'll zero that. And we can come all the way across to this one over here. 401.25. Okay. So then I'll use a calculator to find out what half of that is. Okay, that is 200, that's 200.625. So we'll go across to 200.625. 200.625. Set that to 0. And now I go 2.5 mil to the right, 2.5 mil to the left, and then I'm going to get my center marking ring absolutely spot on in the center. Okay, come across 5 mil. Okay. Then we can see what the distance is from there to here. And that is 198. Okay, so we'll zero that. Bump that speed up to 200 because we're going to try that 0.6 depth and see how we go. Okay, so 198, let's remember that. So we're going 0.6, 6, then 198, so 194. There we go. Okay, that time we did not chip the tip, so that is of course awesome. We'll come across 5 mil. Still no chips, marvelous. This one's 197.5. Come across another 5 mil. 0.6. Zero chips, marvelous. So the reason you saw me put my hand like this on the knurl is because you might be able to see here, there's a little bit of chatter just due to the length of the bar sticking out. And so me doing that just quieted that chatter down. It's not a big deal because once we use the knurling tool, it's going to erase all of that anyway. Okay, so we'll move along another 5. Okay, and this is 270. Okay, we did pick up a chip right at the very end here, which is no big deal since it's right at the very end. If it had chipped earlier over here, it would have been an issue. Anyway, we're finished with that tool now. We can run it back and then knurl it. Let's go to 800 RPM. We might have to slow down the RPM because we're getting a bit of oscillation in the bar now. All right, last section, ready to knurl. Okay, we just got to slow it down to 300 RPM for the final portion because this is getting too long and it's starting to oscillate. There we go. We're just going to put some oil on the bar to protect it. Okay, there we go. Squat bar completely knurled now, ready to heat treat, blacken, and then it'll be ready to calibrate and assemble.